Hey guys, welcome to Happy Math. In this video, I will continue talking about partial fraction decomposition. And we're going to look at a little bit more sophisticated example. And in this example, we have the leading part on top, extra 4, bigger than the leading part on the bottom. That means this is improper fraction. So we got to use a long division to simplify that first. Turn into quotient and then remainder before we can perform the partial fraction decomposition. So first of all, let's write down the dividend. Numerator x to the 4th minus 2x cubed plus 9x squared 7x adding 11. On the bottom we have x cubed squared adding 2x minus 2. Notice that there are 4 terms on the divisor. That means we need 4 terms from dividend. And then the standard procedure when you perform a long division, using the leading term from the dividend x to the 4th divided by the leading term from the divisor x cubed. So the quotient is the remainder we put on. The quotient is the this term we put on top. Okay, so the quotient x goes here. Right? And then step 2, we multiply the quotient x by the entire divisor x cubed x squared and 2x minus 2. Distribute it. The 4 terms x to the 4th, leading term minus x cubed, adding 2x squared minus 4x. Then we're going to put all those 4 terms right up by the leading term. 4th minus x cubed, 2x squared minus 2. Then we subtract it. And from there, we simplify a little bit. So x to the 4th is cancelled. Minus 2x cubed, 2 negative turn positive. Adding x cubed is minus 1x cubed. And 9x squared minus 2x squared is 7x squared. And minus 7x adding 2x is minus 5x adding 11. Then now, following the same procedure, then we take a leading term, negative 1x cubed, from the dividend by the leading term of the divisor, and divide that. The quotient is negative 1. The negative 1 goes on top. Now you multiply the negative 1 by the divisor x cubed minus x squared adding 2x 2. So distribute it. We get negative 1x cubed adding 1x squared minus 2x plus 2. I'm going to copy those 4 terms, put it back into the long division. So negative 1x cubed goes here, adding 1x squared. And minus 2x, and adding 2. Now find the difference. Subtract it. Now we're going to cancel this here. 7x squared minus 1x squared is 6x squared. And minus 5x adding 2x, that's minus 3x. 11 minus 2 is minus 1. So we end up with the remainder. Okay. So from here we're gonna simplify a little bit. So we write this whole thing as a quotient x minus 1 equal plus remainder. This is remainder 6x squared minus 3x minus 9. We're adding 9, right? here is 11 minus 2 is 39. Okay, plus 9. Okay, then over the divisor, which is x cubed, x squared, and 2x. Okay, so we're going to perform a partial fraction decomposition just on the fraction part, right? Then first of all, we need to factor the denominator. We factor this denominator. Factor by grouping x squared goes first, x minus 1. Group the first two, group the last two. For the second group, GCF is 2. Factor out that, x minus 1. On top is 6x squared minus 3x. Now I'll factor by GCF one more time. So 6x squared minus 3x over minus 1. X squared plus 2. Okay. Now we're going to decompose this part. So we have a linear factor on bottom. On top of the linear factor must be constant a over x minus 1. And then on top of the quadratic term must be a linear term, so dx plus c. Goes on to the second factor. Now again, we're using LCD. So the LCD here is x minus 1 times x squared plus 2. So copy that 6x squared minus 3x 9 over x minus 1 x squared plus 2. Okay. Now for the first factor on the right, you multiply both top and bottom by x squared plus 2. For the second one, you multiply both top and bottom by linear factor x minus 1. And then from there, we're just gonna simplify further. We get 6x squared minus 3x. Adding now, both sides have the same denominator. And that's a key thing. Right? We try to make sure both sides have the same denominator, so we equalize in numerator. And this process requires a lot of algebras, so make sure you review some of the algebra skills before you tackle this type of problem. So now same denominator, so numerator must be 6x squared minus 3x, and 9 must be the same as 8 times x squared plus 2 plus dx plus c x minus 1. So if you observe this equation, we can solve this using two different methods. I'm going to show you both methods. So for the first method is just observing this. If you make x let x equal to 1. If x equal to 1, then this whole thing becomes 0, right? So we're eliminating O, B, and C at the same time. So on the left, we get x times squared minus 3 times 1 times 9. On the right is 8 times 1 squared plus 2. And right here, we get this whole thing becomes 0. Okay? Because 1 minus 1. 1 goes here, becomes 0, then the whole thing becomes 0. And you simplify, you get 6 times 3 and 9 on the left. On the right is 8 times 3. That means 3 plus 9 is 12 equals 3a. That tells us 3a equals 12. Then a equals 2 by dividing 3 on both sides of the equation. You locate the first variable a. Okay. So that will do it. Okay. So once you know a, and the second part is observe this. So the leading term 6x squared comes from two sources. come from here and then here. That means 6x squared should be equal to ax squared plus bx squared. So now if you factor x squared here, a plus b equal to times x squared, 6x squared. Same x squared, so that means a plus b must be 6. And since we know a is 4, then 4 plus b equals 6. That means b must be 2. So b equal to 2. So now we locate two variables, a and b. So in terms of finding the c, we're using a constant. So the constant term comes from two sources. Come from a times 2. That's a constant on the right. Also c times -1. That's another source of constant. On the left, constant is only 9. So step 3, 9 should be equal to the constant on the right, which is 2a minus c. Okay. So that being said, so we plug in the 4 here. 9 equal to 2 times 4. So that means 9 equal to a minus c. All right. Now subtracting 8 from both sides of the equation, we get negative 1. No, we get 1. Equal to negative 6. So c must be negative 1. 1 equal to negative c. So multiply both sides of the equation by negative 1. Then c must be negative 1. Right. So now in that case, we locate both a, b, and c. Right. And you can also solve this problem by setting up the system of linear equations. Okay, so let's look at that also. So again, we get 6x squared, 3x, 49. Left, right, it's a times x squared plus 2 plus bx plus c times x minus 1. Now we're going to expanding the right hand side. So left is 6x squared minus 3x, 9. On the right, distributed, we get ax squared plus 2a. Adding dx times x is dx squared. Dx times -1 is minus bx. And c times x is dx. C times -1 is minus c. Now we're going to separate into 3 different terms. So 6x squared minus 3x, adding 9 on the left. So the square term comes from ax squared, bx squared. And again, we factor out the x squared, so we get a plus b times x squared, right? And then the linear term comes from these two. So if we factor out negative x, so we'll factor out just x, right? So it becomes minus b, adding c times x. And also we put constant together, so plus 2a and c, those two are constant. Now equalize these. So that means a plus b must be 6. For the square term, the coefficient must be the same. For the linear term, the coefficient must be the same. So minus b plus c equal to negative 3. And then for the constant 2a, minus c must be 9. Okay. Now we get a system of linear equations. We can try to solve for a, b, and c. Okay. So step 1, right here we can, for the first equation, isolate b, right? So b is equal to 6 minus 8. Then it goes into the second equation. Then second equation becomes minus 6 minus 8 adding c equal to 3. So now if you look at the second and third equation, 2a minus c equal to 9. Now these two equations only have variable a and c. So simplify a little bit further for the first one. So negative 6 so again negative 6 adding a adding c equal to 3. So now move that 6 to the right hand side. Okay, adding 6 here, adding 6 here on both side equations, so we get a plus c equal to 3. So 2a minus c equal to 9. Now this is a system of linear equation, two variables. Now we can add these two equations, easily get variable a. So get 3a, c get cancelled, 3 plus 9, that's 12. That means dividing 3 from both sides equation, a equals 4. So we find out the variable a. You know a, and you know b, because b equal to 6 minus a. So b equal to 6 minus a. So that's 6 minus 4. So b equal to 2. And once you know b, then you know c, because we can just plug into the one of this equation here. A plus b equal to 6, right? So if you know we got b and c, plug into the second equation. So c, since b is 2, so minus 2 adding c, that's equal to 3 from this equation right here. Then adding 2 from both sides of the equation. C equal to 1. Okay. And it should be the same as the other method. It's a little bit more systematic. Just working on solving system linear equations. Get to the bottom of this. Eventually, this in terms of partial fraction decomposition, this one becomes so x minus 1. Right? That's the fraction part. And then it's 4 over x minus 1 adding 2x minus 1 over x squared plus 2. Okay. This is a complete result for this partial fraction decomposition. I hope you learn from this method. And that's the end of the